Okay, this is the next problem in this series, and it relates to conservation of linear momentum. So the problem is stated here. This is there's a shell, explosive shell, which is initially stationary, and it explodes and it splits into three parts, not equal, into three parts. And part 1 of mass 3 kilogram flies off in the west direction. Part 2 of 4 kilogram in the south direction, and the part 3 is of 4.2 kilogram. It would fly off in some direction with some velocity, and that is what we are required to find. So first we do is let's draw a diagram here to see what's happening here. So this is my shell, and it is initially stationary. After the explosion, this is my part 1, and I will call it M1, and V1 is equals to 12 meter per second. Oh, okay, so in the question I have not given the velocity, but I'm writing the velocities here in the diagram. So question in a sense is incomplete. You will normally have the velocities given as well. Yeah, you will have velocities of two parts given, and the third part you'll need to find the velocity. So that's this 12 meter per second wasn't given, but I'm giving here in the diagram. This is my M2, and that is 4 kilogram, and its velocity is 10 meter per second. Merely by looking at this diagram, by looking at these two pieces flying off in this direction and in that direction, we can intuitively see that the third piece must move in that direction, so that the total momentum is 0. Right, so now this shell, we can take that as an isolated system. Therefore we will have P initial would be equal to P final, because there is no external force acting here. We normally write here that as per principle of conservation of momentum. Alright, so now initial momentum here, because the shell was stationary, so initial momentum Pi equals to 0, and that tells us that Pf has to be 0 as well. Now Pf is the final Pf after the explosion. So after the explosion we got three pieces here. Each of them will have their its initial momentum, its individual momentum. So P final, total momentum after explosion, will consist of three parts, and that will be, I can write like this: P1, P2, and P3, where P1 is the momentum of mass M1, P2 is the momentum of mass M2, and P3 will be the momentum of mass M3, which is of 4.2 kilogram. And the V3 we need to find here. So this P final will have to be 0. So what we have here is, because we are finding P3, that will be equals to minus P1 minus P2. All I'm doing is I'm trying to solve for P3, which I can write in a better way as P1 plus P2. And it makes sense. It makes sense that you add P1 and P2, you add the momentum of this piece, add the momentum and with the momentum of this piece, and you add them together, and that should cancel out the momentum of the third part. That will give us a total momentum of 0. So looking at this thing here, this expression here, minus P1 plus P2, we can see the way ahead. We can see that we need to find the P1 and sum of P1 and P2, and then we need to take the negative of that. Negative means we need to take the reverse of, we just need to reverse the momentum P1 and P2, sum of P1 and P2. So we'll start with finding P1 and P2. Now P1 is, we can find that, but before we do that, I just want to write the directions as well. So I will say that we need some reference direction. So I will say this is my north direction. All right, so just reference directions so that you can write all the directions. So I'm taking geographical directions here. So P1 is equals to 3 kilogram times 12 meter per second. That gives you, I'll write the unit Newton second, and it is in the direction due west. So 12 times 3 is 36 Newton second due west, and likewise P2 is equals to 4 times 10 Newton second, which is equals to 40 Newton second, and it is due south. All right, now addition is straightforward. So we already know how to add vectors. We draw these two vectors and we put them, we connect them, we chain them, we put them in a chain from tail to tip. So this is the first vector that I'm drawing here. This is P1, which is a length of 36, and that's my starting point here. And the other vector is 40, so that is due south, that's 40 here. And this is my P2, and P1 plus P2 will be this, P1 plus P2. So I can see from Pythagoras theorem that P1 plus P2, basically I'm talking about the length here, length of this vector P1 plus P2, and this length is indicated by this, we call it magnitude of P1 plus P2 is the square root of 46 plus 36 square, and that gives us 53.81 Newton seconds. And we will need direction as well. I'll call that angle theta. So I can write that here. Theta is equals to, just use elementary trigonometric ratio, 10 is equal to opposite over adjacent, which gives you 40 over 36, and that angle is 48.01 degrees. So now I can write my P1 plus P2 completely. I can describe it completely, and it is 53.81 Newton seconds, and the direction is, we can see that this is my west direction, and from west I am moving towards the south, so angle will be west 48.01 degrees south. Once we find P1 plus P2, now we can find P3. We already saw that P3 is equals to, we saw it here that P3 is equal to minus of P1 plus P2. So P3 is equals to minus of P1 plus P2, which is minus of 53.81 Newton seconds west 48.01 degrees south. Negative of a vector is essentially nothing but reverse of a vector which is reversed in direction. So this will be 53.81 Newton second, and the reverse direction is east 48.01 degree. Now just to explain how I get this, so this is that's my north, and what direction I have is this is, sorry, the direction, this is 40, no, that's the wrong direction, wrong angle I have marked here. This is here, that angle is 48.01. So if I reverse it, I I reverse this vector and I go in the opposite direction here. That angle is 48.01, so that angle will be 48.01 as well. So this time so direction of this angle will become from east, we are moving towards north by 48.01 degrees, and that's what I got here. Okay, so let me write P3 here again. So P3 is equals to 53.81 Newton seconds east, 48.01 north. Before we move any further, I just want to tell you how to find the reverse of a vector like this. So this here, you see this W west 48.01 degrees south. If you want to reverse it, you just convert W to east. Reverse of west is east, and reverse of south is north. That's what you need to do essentially, and you will have reversed the direction of your given vector. Okay, P3 is mass time velocity, so mass is 4.2 kilogram, and V3 is, this is my V3, I need to find it. This is equals to 53.81 Newton second east, 48.01 degree north, and that gives my V3 is equals to 53.81 over 4.2 meter per second east, 40.018 degree north, and that will give us 12.81 meter per second east, 48.01 degrees north. That's the velocity of the third part.